So, what is the ideal gas law? Well, it's a law, or an equation, that is true for all ideal gases. But remember, real gases are never completely ideal, so this equation is used just to estimate things about gases. You can assume they're ideal, because if you don't, the equation is even more complicated. Now, what things can we estimate about gases? There are four: the pressure, the volume, the number of moles, and the temperature. The ideal gas law is an equation with these four things, as well as the gas constant R, which will always be the same. Since R is always the same, if you know three other things, then you can solve for the last thing. However, you cannot just plug in values with whatever units you want. You need to have the right units. Temperature must be in Kelvin, the number of moles must be in moles, the volume must be in liters, and the pressure is a little bit more complicated. You see, the units of pressure need to match with the units in the gas constant R. Because the gas constant R is usually R equals 0.08206 or 8.314. These two numbers are the same, just with different units, one with atmospheres or ATM, and one with kilopascals. So for the pressure, you usually use units of ATM or kilopascals, depending on which value you already know. Just remember to use the R with the same unit. And that's it. Just use the right units and you can use three things to solve for the other thing. We'll do an example next. A balloon filled with helium gas has a volume of 8.0 liters, a pressure of 1.2 atm, and a temperature of 27.0 degrees Celsius. How many moles of helium gas is there? We'll start with the ideal gas law. We want to find N, so we'll substitute in all the other things first. The pressure is 1.2 atm. The volume is 8.0 liters. Now, the pressure is in atm, so the gas constant R is 0.08206. And the temperature is 27 degrees Celsius, right? Actually, no. It has to be in Kelvin, so we convert it first. 27 degrees Celsius plus 273 is 300 Kelvin. So the temperature is 300 Kelvin. Now we do some math, and we get 0.39 moles. So there's your answer. 0.39 moles of helium gas, correct to 2 sig figs.